6:30, so I'd like to thank you all for coming. I'm just going to briefly introduce shop architects and Chris Sharples in particular, who's done us the honor of coming up here to speak to us tonight. So since 1996, shop has modeled a new way forward with their unconventional approach to design. At the heart of the firm's method is a willingness to question accepted patterns of practice, coupled with the courage to expand beyond, where necessary, beyond the architecturals. Chris Sharples is a founding principal of shop with a focus on successfully integrating academic and cultural projects into the urban environment. He's served as a principal for many significant projects, including the Barclays Center, Site Santa Fe Gallery expansion, the 10-story residential timber building on 475 West 18th, Google headquarter offices, and currently the Uber headquarters in San Francisco. Beyond the studio, Chris has earned a reputation as a thoughtful leader of his generation of innovative architects and a powerful advocate for design quality and contemporary city building and addition. In addition, he has led shop's efforts in collaboration with several research institutions to develop and bring to market proprietary facade integrated solar technology known as Helioptics, scheduled for commercial release next year. Chris has held teaching positions at Cornell University, Parsons School of Design, Yale University, the City College of New York, Columbia University, and the University of Virginia, and he lectures internationally. And as he mentioned before, he actually did several degrees before architecture, so he is a very well-versed jack of all trades. So it's my pleasure to introduce Chris Sharples.
Thank you. It's great to be here. You know, it's not really that difficult to get up here from New York, especially when you land at Billy Bishop. It's almost like crossing the street. And you guys got great weather right now. And to be honest with you, I might be spending more time up here if the elections go the wrong way. Anyway, like I said, it's great to be here. I got a lot of stuff to show you, so I'm just going to jump right into it. Here, let's see if I do this right. I did something wrong. So how do I move this forward again, Leo? I forgot. Oh, let's see, that's one. Okay, got it. All right. See, technology is always going to be an issue. We use technology quite a bit at shop. But, I think the way, as it was mentioned, I do have degrees in other fields. All the founders of shop come from different academic backgrounds. We didn't actually start in architecture. Greg has a degree in finance. My twin brother has a degree in structural engineering, Corey in business, Kim in fine arts, and I'm sort of a jack of all trades, history, political science, and fine arts. So I'm sort of good at cocktail parties, I think. The thing about having those other disciplines has really influenced the way that we've sort of developed our practice. And in a way, we don't really begin the design process by thinking about what the form should be or necessarily what the program is or even the site, but sometimes just asking questions about things that might be even outside the realm of the project in particular. And in a way, sitting there and listening to the client, understanding what's going on in the community, the issues of politics and finance. So in a way, a lot of that begins by asking questions and listening. And the other side to the practice has to do with how we've embraced technology. We came out of school in the early 90s, mid-90s, and technology was taking shape in the form of CAD, but also for us, more importantly, 3D modeling. And it's funny when you look at it in the context of the history of architecture, sort of like Back to the Future, the level of complexity that you see just in Gothic architecture is almost three-dimensional puzzle. Architecture is a very complex game on many different levels, and technology has allowed us to get back into it where we can actually begin to talk and work directly with the people who craft our buildings. And almost rethinking the way that we manage complexity. When I came out of school, everybody still, plan and section was the way that you manage this information. But really, it's moving beyond a representational document to an instruction set. So, when you look back at those model kits you built when you were a little kid, hundreds of pieces, axonometric drawings, you never felt like you had to pick up the phone and call Tokyo and say, how do you put your kit together? But that's what happens on the job site all the time. All these RFIs always asking, how do you do this? So what we started looking at, especially on some of our earlier projects, was how we began to manage this information in model form and begin to index it, take it apart, so we can actually rotate it around and show it to the people who are actually going to build it. Much easier than looking at something in 2D and then trying to translate it into the third dimension through the fourth dimension. Things get lost. So very early on in the practice, we started looking at these smaller projects as a chance to test out some of these ideas. PS1 was a very small project for a contemporary art museum that had this summer program. And so we developed these pavilions that would be occupied during the summer, and it was based on the theme of the beach. But what was amazing, we modeled everything in the computer, but instead of generating plans and sections, we literally developed a set of instructions. These drawings here, you can't really see it because they're all sort of faded, but each sheet is about 1 meter wide by 5 meters long, ganged together to create, a 15 by 20 feet long jig where you would actually build literally on the drawings. So in a way, taking the idea that instead of looking at a drawing, you actually literally were building off of it. And so this came together, and we didn't really even think, this wasn't really polemical in the sense that go, oh my God, this is the Rosetta Stone for how we should be looking at architecture. It wasn't until a decade later that we realized how this was really the origin to our sort of thinking about how important that digital model was and how it carries forward. And really, so there are just a series of questions that I posed through this talk. And the first one is, what does it mean to be a master builder today? And in a way, it is all about this idea of not just designing, but how you execute on the design. How do you collaborate with the people who are actually going to put the building together? And you don't do that, in that first project. You don't try and tackle everything in that first go round. So for us, on one of our earlier projects that we did in 2001, the Porterhouse, we literally focused on the envelope of the building to sort of test out some of these concepts of direct-to-fabrication. Here we literally took raw zinc meter by 3 meter sheets and began to nest, the panels on that, and actually generated the shop drawings. Emailed those shop tickets out to Malloy Laser on Long Island, where they were actually laser cut, and then broken, and then brought back to the site. These are some of the index sheets that we generated for that. And then you can see on the panels, before the white plastic's removed, the information that tells you exactly where that panel goes on the building, so it's sort of like a watermark. And for us, it was a great opportunity to create a highly unique, beautiful, simple zinc facade with a variety of different panel shapes for the conventional cost of construction. We did this project for about $45 a square foot. That's 2003 numbers. But it was a chance to create something iconic at a conventional price. And I think the way, we wouldn't have been able to do that without the use of this type of technology, that sort of interface between the design process and the actual making. And one of the challenges we had is, in New York, we have a lot of pigeons, and the fear was, you get a pigeon on this beautiful zinc, we would have droppings all over the building. So we actually got in contact with the Natural History Museum, and they told us the angle of repose to keep your bird off of there was about 32.5 degrees. So we created what we call the pigeon slide. And to this day, Porterhouse does not have any pigeon poop on it. It's not, simple things like that can just ruin a building. And then there's some views. And then, so what was exciting about this, so this is 2003 when we finished this. And then in 2009, we had a chance to supersize this concept of, instead of doing a 10-story residential building, actually beginning to wrap a whole arena in an envelope which we would design but also execute with the fabricator. we didn't start off with this project outright. Actually, Frank Gehry had come up with a brilliant master plan where he had a collection of buildings that would basically cup the arena. And actually the structure for all these tall buildings actually went through the arena. The thing is that in 2008 we had the financial crisis, and there was no way the developer could finance the whole project at one time, so they had to break that apart. The challenge is, in December of 2009, they had to have the shovel in the ground, or the developer would lose about $300 million in tax-free bond financing. And so there was no way, even if Frank Gehry moved ahead, that he would be able to get those CDs done in time to get that project online. So the design builder, Hung Construction, told the developer, if you want to meet that deadline, you basically have to have already designed this building and built it somewhere else. And that's exactly what they did. They started going around the United States looking for an arena that would fit on this site. And they came up with the Conseco Fieldhouse. And unfortunately, the problem with this is, Mayor Bloomberg and Amanda Byrd, head of city planning, just approved the Frank Gehry scheme. And then they got a bait and switch, which, was a field house from Indianapolis. And so we got a call, they came into the office and they said, we need something more iconic than this. And we were already thinking, oh, well, we could change this, we could change that. And they said, no, the steel's been bought, all the precast has been bought, you can't change the shape. And I remember in that meeting, we're like, well, that's like putting leotards on a pig. What are you going to do about that? And we figured if anybody was going to do this project, it should be a New York office. So we put our heads together and started thinking about how we could transform this into a building that really was very much a part of Brooklyn, have a sense of a civic presence in the downtown. So the first thing we started doing was, how could we break the mass of this building down into different scales? And so the first thing was, we have creating these bands, and then at the same time, opening the building up to the city around it. There's a major transit hub at the foot of the plaza, and the whole idea was creating this view where you could actually look from the plaza all the way into the bowl. And then starting to shape the form of the building to give these views out back to Brooklyn. And then creating openings along the side for retail and the VIP entrance. But for us, the breakthrough of this project was really about, you're plonking an arena in downtown Brooklyn, and you've got to give it a sense of a civic presence, a place where people will gather before they go and see these events, concerts, or sports. So we created this porch with an Oculus in it. So as you're moving up through the train station, you're actually looking through this space. And that Oculus actually becomes the marquee for the building. So a little more about the scale of it. One of the key things for this project was we put the main concourse at the same level as the sidewalk. So when you go in, you're literally at the main level of the whole arena. You're not going up, you're not going down. You can actually look right out into the bowl. And then at the upper level of the halo, we have a break, and that's in line with the heights of brownstones that are to the east and south of the building. And then to the west of the building, you have much higher structures. So again, trying to make a proportional relationship to those as well. But as I said, we have 9 subway lines converging at this point. People are coming up, so it's really transit oriented. This is not about people driving their cars. Pretty much 95% of the people come to this arena using public transit. And here you come up and you have this incredible view through the Oculus, but then you have this view directly into the bowl. You can see the scoreboard from the plaza before you even come into the building. So this was the rendering that was generated 6 days after our first meeting. Then this was the one that was done 3 months after we had basically done all the analysis, costing analysis and modeling analysis to make sure the project would be on budget. And then this is what it looks like today. And the reason I show you is we basically use the same model throughout the whole process. It's a very iterative process. It's like designing a suit. As you're designing, you're tailoring it, you're having your second fitting. But you're not like doing one model and then throwing it away and then starting a new model when you go into construction. The model actually carried through design into the construction process. And the way we did that, we started breaking down portions of the facade so that we can analyze it for quantities, so that we could really begin to optimize the surface area to get it within budget. So this really wasn't about compromise, it was more about what we call design optimization. And then this is a picture of the CATIA model. We use CATIA predominantly for our envelope work because we can go directly from design into fabrication with this technology. Aerospace technology that Dassault Systems produced. And you can see here are just some view captures of some of the mega panels for the facade, and then one of the prototypes that was developed for wind tunnel testing. So once we had gotten approval to move forward, we then went into fabrication. What you see here, there's 12,000 panels on this building. They're all different. And you see below this is an unfold. It's basically taking all those panels and then basically laying them flat so that we can begin to understand how we set up the break patterns. So imagine you have 12,000 panels, and the old school way of doing it is you have one person doing a shop ticket, or a bunch of people doing a shop ticket for each one of those panels. John Sharon and Brian Sweeney from our office received information from the facade fabricator saying this is the information they needed to calibrate their machines. And so what they did was they set up a script that automated the whole process of generating these templates for the panels. So instead of having a room full of people drawing tickets, you have a few people basically managing the files using the script. And then design optimization, we saved $250,000 just in material by just optimizing the sheet efficiently. And then we turned the factory into one big dry cleaning rack. We wanted to do this building, use weathering steel. Brooklyn has this industrial history, and you have the brownstones. I mean, they built aircraft carriers and battleships there. And so we wanted a material that wasn't about stainless steel and glass. It was really a Brooklyn attitude. And so in order to get that material that way, we actually created these dry cleaning racks, and we hung the panels in sequences, breaking them into groups of 4,000. And they went through a wet and dry cycle 12 times a day for 3 months to get them to about 90% rust. And then the gang came up with a iPhone app where you can actually track where those panels were in the process, whether they were weathering or whether they'd been broken or whether they'd been put up on the building and they get dropped into a web-based model, which you could see where you are. So it's very, very tied to how the model is sort of taking you through the process. And here you can see more on the truck, up on the building, and then the upper halo, and here it is sort of nestled in downtown Brooklyn. And this is a view looking along Atlantic Avenue. And then this is the Oculus. This was actually opening night for the Jay-Z concert. So that Oculus, we've have artists do pieces in there. Obviously, there's advertising, but this has sort of become one of the the new centers in downtown Brooklyn. And so we went on to do all the public interior spaces, bringing in reclaimed wood, sort of address some of the bars, and then the black box sort of space of the arena itself. So we took some of that, and again, we continue to you focus quite a bit on developing envelopes on a lot of our buildings. In this case, this is a residential project that's finishing up on the east side where we're using copper. So that's what it will look like today, and then that's what it's going to look like hopefully in 10 years. It's basically inspired by the color of Statue of Liberty. Again. And so this picture, so what you see here is this is the Revit model. So you're seeing all the surface has been turned off, all the floors have been turned off. What you're seeing is all the mechanical infrastructure that is needed to supply air and, you know, cool air and heat and plumbing, sprinklers to this building. It's that kind of integration, that kind of complexity that we're looking at in terms of the future of how we use that model, and then how that model gets turned over to post-facility management. You see some of the bridge structure. The unique part of this project is that it's a rental building, and the amenity space bridges the two towers and overlooks the East River. On one of the bridges, we have a pool, and an infinity edge on the top, and a bar. Great view of the Statue of Liberty. So that's a fun project, but again, you know, an opportunity to, you know, how important the model is in terms of achieving this level of workmanship. So another thing, so there are projects where you come to the site and the context is everything. I think for our very first project, Waterfront Park in Greenport, Long Island, it was all about the context. We had won this commission, and the last thing the village wanted to see was a New York office come up there and then tell them how their architecture should look. And for us, it was really about, you know, creating a new sort of rebirth, a new renaissance for the village, and through this idea of a park. And so it's made up of many different things. We've got a harbor walk, a carousel house, an amphitheater, a seasonal skating rink, a camera obscura, a harbor master's house, and all these elements are knit together by this path that crosses the site. There's a picture of the camera obscura with the Mr. Field, so that's the HMS Bounty in the background. And the seasonal skating rink, a moment of Norman Rockwell here. But, you know, the challenge was, you know, in these community meetings we have, you know, we're surrounded by all this beautiful Victorian architecture, and there was this concern that we were going to impose some sort of modernist tenet on them. And so one of the programs was to create a carousel house for this antique carousel they had. So, you know, almost looking back at the concepts of the Crystal Palace, you know, creating this beautiful glass house, but with these huge bifold doors that would promote natural ventilation during the summer, and then during the winter they would close up so that you could use it all year round. And then with the camera obscura, which was the last of the buildings that we did on the project, we decided that we would model this whole thing in the computer from start to finish. And what you see here is this is some of the drawings that show. For those who may not know what a camera obscura is, it's a black box with a pinhole at the top that light comes through, it hits a lens, and gets projected down onto a surface with a mirror, and creates this incredible vivid image of what's going on outside. So what you see here is basically the Rhino model of the carousel house, a worm's eye view looking up into it. And what you see here is all the components that are needed to assemble it. Again, thinking of that model kit again, how you go about explaining all the different pieces that go into putting this building together. And here, the same files that we used to pre-cut all the pieces for the actual building were the same files used to make the model. So those are all the pieces you need to build a camera. There's interior view there. So, you know, so if PS1 was sort of that first step of rethinking about how we manage complexity through these models, the camera obscura was like thinking about how much of this could we, you know, fabricate off the shop and use that model as sort of literally as the instructions for the project. Another project that is highly contextual is this tower that we're doing in downtown Brooklyn, 9 Decal. It's formed at the confluence of two major roadways, Fulton Street and the Flatbush Avenue extension. And one of the biggest challenges with this project is the shape of the site. It's a triangle. The other challenge, and it's a beautiful challenge, is there's a beautifully historic landmark bank building there. And just the quality of craftsmanship that went into the materiality, it's definitely something that you don't want to ruin with putting a building that doesn't try and respect some of the qualities of what this is all about. The challenge is it's a very tough site because of its shape. And so we looked a lot at some of the geometries that were inherent in the design of the bank itself. You know, the hexagon, you know, triangles, and using that information to actually begin to proportion and map the site and see how we can integrate this new residential project without compromising the qualities of what's already there. And so in a way, in terms of a contextual way, we're literally using the geometry, the mathematics of the bank building to inform the mathematics of the actual residential tower, with this idea of an interlocking hexagon, pair of hexagons. The other thing that's sort of inspired is the fact that you're surrounded by all these different neighborhoods that are actually converging at different angles. And the great thing about a hexagon, instead of working with 4 sides, you're working with 6. So the idea is how the building actually begins to face these different orientations to these different neighborhoods, and then with the setbacks sort of spiraling up. And starting to think about sort of, again, the materiality, how we could take inspiration from the banking hall and create that sense of, also that sense of verticality. So we started thinking, you know, maybe it's a number of different materials, also different profiles, almost thinking of it as like a puzzle. And so we started creating these different shapes. Some of them would be in terracotta, some would be in black and aluminum, some would be bronze, some would be stainless, and started thinking about how we use those colors to sort of organize how the building starts to grow. But also how we start to organize those profiles in terms of the facade of the building. So literally, this is a large-scale model. We like to work in big models in the office. But we started to treat it almost like a puzzle, where you take these, there's over 50 different profiles, and you start mixing and matching them, moving them around, looking for the best sort of possible combination. And then taking those ideas, and towards the bottom, we max the lighter colors, and as the building rises up into the sky, the colors get more dark. It's a close-up view, and then there's a view of it. It's what you call a drone shot. And then also thinking about how we could use the fluting of the columns to begin to sort of dress the base of this building, the new entrances into the residential tower. So we basically inverted the relationship of the fluting and lofted between the two to generate, you know, another sort of a hybrid profile that changes as it goes up the building, and this will be along the base. So again, using a lot of the contextual qualities of the landmark to inform the design. And the last project I'll show you how we're doing that also with another landmark, the Steinway Tower in Midtown. But the banking hall is just exquisite. This is going to become the commercial space for the project. And then there's a view from the Brooklyn Bridge. This is from the Manhattan side by the seaport. So this is another one that's sort of, you know, when you start working on projects that are in the public realm, how can the design, you know, connect people? I think for us, after doing Greenport, we won a commission to do a 2-mile stretch of waterfront along the East River with a new park esplanade. And the first thing that it was like supersized in terms of the amount of community board meetings, DOT, local and state agencies. I think after we got through phase 1, I think we had over 130 meetings with different city agencies to go through this whole process. Very intensive. So you have to connect with a lot of people there. But the other thing we analyze is with all the new parks coming down the lower Manhattan, if you count them all together, Governor's Island, Brooklyn Park, the Esplanade, Battery Park, it's about 400 acres, half the size of Central Park. All this park space coming to lower Manhattan. So for a city that's changing and becoming more 24/7 in lower Manhattan, families moving down here, this was a great thing. The challenge was, you know, connecting these people to this waterfront And at that time, when we started in 2003, this is what we had. We had garbage, we had parking lots, we had chain link fence. So the first thing we did was rent a helicopter and fly around the 5 boroughs and look at the way that the city met the waterfront. And down where we were, this is pretty much how it is. You had Water Street, you had Front Street and South Street, then you had parking, you had the FDR Drive, and you had a bunch of warehouses. So it was not a place where people would want to go and touch the water. So the first thing we did was get rid of the parking, add landscape, add bike paths, and actually take advantage of the FDR as a free roof to put new programs underneath. And so here we started to sort of begin that reconnection of people to the waterfront with this approach. And so this is the view. At every cross street, we created a step down. So where the old slips would be. So this one's over at Wall Street. And you can see there's the FDR there, and there's actually a dog run underneath at that point. But really bringing landscape, bringing the sort of the old, Manhattan quality of Manhattan back to the East River. And there's, moments where we created bar stools. Nobody's going to sit at these places, but actually people come down here and eat their lunch here. They pull out their laptop. They do work during the summer down here. It's become a big hit, and actually I think these are actually being prototyped for other parks along the waterfront. There's the step down again. So at high tide, the water does come up to the lower step at night. And then this is one of the restaurants that was opened up recently underneath the FDR. This is Industrial Kitchen. CC Views. So there wasn't much we were allowed to do. We weren't allowed to touch the FDR. We actually were allowed to paint one side, but you can see it's still rusted. The DOT was very protective of their infrastructure. And then we also are developing a series of pier structures, Pier 15 and then Pier 17, which is in construction, and Pier 35. And the idea here was to create these double-decker piers where you could actually utilize commercial on the lower level, maritime activities on the lower level, and a new park on the upper level. And that's the view again. Looking towards Brooklyn before Brooklyn Park was finished. Looking back at Lower Manhattan. And there it is at night. So this was one form of how design was sort of connecting people, in this case connecting people with this vast waterfront. Another one, which is actually, let's say at a more sensitive level, is a competition we recently won for a Veterans Resource Center at Syracuse University. So in the history of veterans in the United States, after World War II, we had the GI Bill. And a lot of universities just had a huge influx of veterans coming back from Europe and from the Pacific. This is what Syracuse tripled in size, and they had no room to put all these veterans, so they put them into these bunk houses right on campus. Today, you don't see that. The interesting thing is you don't really even see the veterans. They're sort of like compartmentalized in different places of the campus. And the idea here with this resource complex is really to make that connection between not only the campus but also the city of Syracuse, and the veterans really seen as being a part of that bridge. And because it's a challenge. It's not just veterans coming back who want to get a higher education. It's also veterans coming back with disabilities, both physical and mental, both and having lost limbs, their families, learning how to reacclimate. And so this building is not just seen as just another academic building. It's really, in a way, a space where they can come together and really build relationships both on campus and within the community. And so for us, we see it as a gateway, a link between the public realm and the campus. The other thing that was interesting about the project, which we didn't expect when we started the competition, is there's a 1,000-seat theater. So it's really seen also as a civic, having a civic presence where they invite people in from the campus from around the country to come and speak on the topic of Veterans Affairs. Above that, you have all the administrative and classroom spaces that support the center. So one of the challenges of this project when you have people with disabilities is, making sure people can get around and not have to just rely on elevators. So all the surfaces, all the platforms in this complex are connected by a series of ramps. In some cases, pulling you through galleries or into the theater or up into the building. We also brought the concept of landscape into the core of the building. And then on the upper level, we created a parade ground, which in a way is sort of the cloistered space for the administrative activities that take place here. And here you get a view back towards the campus. And this is a picture of the model. So you get a sense that how it rises up and opens itself to the surrounding campuses. Again, it's not trying to close itself off from what's going on around it. And here's the view from University Avenue. So this is a project that we're in schematic design on right now. So another area that we spent a lot of time on is how you create, inspire creativity through space. And we've had a chance to work with really interesting companies like Bloomberg, Google, Uber, a few other interesting tech companies. And the idea that a lot of people are in there, they're actually in creative mode. They're scripting, they're coming up with new ideas. What kind of space, what kind of architecture, drives that type of inspirational activity? And so, one disclaimer: we actually didn't execute on Google's headquarters. I'll go into why in a minute. But it was the first project where we actually had a chance to really think about some of the ideas about what is creative space making about. And sitting down and working with the founders. I mean, when we were working with Larry and Sergey, they were riding their scooters and bicycling through their office space. I mean, this whole idea of moving away from just this sort of field of cubicles and creating these different moments where 1 minute somebody's over there playing ping pong and the next moment somebody's over there, working on script. This idea that it's this living community that's moving around, and it's not just one sort of subjected to one sort of type of way of working. So we started developing different plans to sort of deal with sort of different conditions. Sometimes facing towards landscape, the idea of almost like a village. The other thing that was critical to this project was really looking at a zero carbon building. And so this is back in 2006. We hadn't really been thinking about these issues too much, but this was a great opportunity for us to really begin to engage it. And the sort of the silver lining is that my wife, Anna Dyson, who's director of CASE, Center for Architecture, Science, and Ecology, her whole focus is on next generation environmental technology. So what was great was we were beginning to look at how we could take these new technologies that aren't applied, but are actually integrated into the architecture. And here this is a photovoltaic CPV system utilizing concentrator technology that basically tracks the sun within a double skin facade. And what's great about it is it not only tracks the sun and generates a lot of electrical current, also high quality heat, upwards of about 86% combined heat and electric, but it also takes the glare out of your space because it's always pointed directly at the sun. So you're getting that sort of what you call artist light. But the thing that I like about it is it also looks really great. It's not like slapping photovoltaics on your building. It's very much integrated into the architecture of the space. So this is a rendering. So what we're right now in our 18-month commercialization phase. We're actually supposed to be through it by next July. We're working with a manufacturer in Seal Beach, California, named Arzon, on getting this technology to the marketplace. Another thing that she's developed and has patents for is on producing clean air technology using hydroponics. And this is a system, this is not a rendering, this is an actual photograph of the FAB system installed in one of SOM's new buildings, a security lockdown building in the Bronx. So this building, actually the containers that the plants are in are actually the ducts. And basically the dirty air is flushed through the ducts, and the roots, the rhizomes, are taking the particulates out. So this is an example of a workspace where we rendered that whole sort of concept out, and it also works very great as an acoustical backdrop for these types of environments. The other thing, starting to think about when you're organizing all these activities within, you're talking about hundreds and hundreds of people working together, and you start thinking about how do you manage that so it doesn't seem like it's just a sea of people everywhere. And so you start thinking about circulation. You start thinking about places where people come together, the micro kitchens at Google. Food is everything in a way at Google. Everybody groups around food. It's always free, but it's also really good. And that's when people exchange ideas. And the other thing is turning into sort of, in a way, like a hill town, where you have all these different streets and these engineering groups. They're all mixing together. They have these plazas where they come together. And sort of pulling all those sort of ideas together to generate this engineering creative community. And this is sort of like one of the floors. You can see the ramp space that connects all the engineering floors together. It's one of the models. And so that we were really excited. We had just finished CDs, and I was flying in from New York, and it was the day when I left New York. Lehman was still existed. When I landed in San Francisco, Lehman Brothers didn't exist anymore, and neither did this project, because it just, for Google, spending $400 million on a project when the bottom was falling out everywhere else. Obviously, they were doing really well, but it just didn't make very good sense. So the project got canceled. We were extremely bummed about that. So what do? You do a competition. And there was a competition for an innovation hub in Botswana. Botswana, their main resource, financial resource, is in minerals, specifically diamonds. They knew it was going to run out, so they were interested in diversifying. So they wanted to create an innovation hub that would be mainly on biotechnology. So we did this competition, and we took a lot of the knowledge that we had developed at Google and applied it to this project. The only difference is Google was in the northern hemisphere, and Botswana was in the southern hemisphere. So we just put them. But a lot of the inspiration from that project carried over into this. And then again, for us, everything is very iterative. So in this case, we were looking at, it's got an arid climate, but it's also got this incredible delta, bringing those two worlds together. And there's a series of bars which would become the lab buildings, and then connecting them together. And literally the building became this sort of natural self-ventilator where we would, in between each of the bars, labs, you would have these parks. And grade was defined by the parking. We didn't actually dig down. The grade was the parking level. And we had these old growth trees. And so they literally grow out of the parking level into the cloisters. This is sort of what we see. This is sort of like the cloisters of the monastery for the 21st century. And then you have the bridges that connect between the different lab spaces. And again, after having done Google, we became very sensitive to, understanding how building performance, can be managed much more succinctly. And in this case, doing solar analysis, this influenced the way we looked at our models, developed them. This is an overhead view of the project. This is a view from one of the ring roads. So one of the things when the government came to visit us, they're like, we didn't know who SHOP was, and we showed them how we were using technology. And it was so amazing because sometimes we show a lot of this technology to the people in New York, and they're like, no, we like to do it the old-fashioned way. We make money this way. Why would we change? But in Botswana, they were so excited to say, well, you've got to teach us how to use this. We want to use this technology to build a building. At the same time, we wanted to have a connection with the local craft that was going on there. And one of the things we noticed is highly evolved craft in baskets. And you're like, oh, well, how are you going to make a building out of baskets? But it was more about the technique and the geometry, the materiality. How do we take that and bring it into the building? So we started thinking about how could we literally wrap the main conference space, the theater, with this approach. And so we started analyzing, how they would come together and developing some of our own sort of tectonics from that. And then at that point, you take it into Grasshopper, and I know that you guys are doing a lot of this here, so you're quite familiar with that. But then you take those models and you actually 3D print them. And actually the client made their decision based on the 3D printed model, not on drawings or on renderings. It was literally touching the model and looking at it, seeing how the light would hit it. This is a really crude prototype we made in our office. And then we're actually working with a local furniture designer who's actually fabricating this system. And it's compared to what we did, it's highly refined, really, really beautiful tectonic. So it's not only going to become, it works for acoustics, it also works for bringing the air into the space. Here it is over the bar. So at these centers, there's always food and drinking. I guess is how you get the inspiration going. But and then here's the interior of the theater. One labs, courtyard space. And so this project, so again, doing more analysis on how we protect the labs, creating shaders. This is another case where we're actually generating all the shop information in New York and then working with a fabricator in Cape Town, South Africa, who's fabricating it. And you can see here's a mock-up on the building. It'll be the largest brown roof in all of Africa when it's done. And this is some shots as in construction. Very different sort of, my twin brother goes here a lot, and it's very different, obviously, very different construction environment there. There's one of the old road trees. We don't have animals come on our construction sites. Well, maybe we do, maybe some rats, but we usually don't have goats. But if you think if OSHA was here, they'd be controlling this. But so that project will be done in the next year. So another project, and this one again, this comes back to the idea of how you design a project in a city. How can it embody qualities of that city? I think when we won the commission to do Uber's headquarters in San Francisco, it was all about how you navigate the city. I mean, when you open the app and you see where the car is and it takes the wrong turn, you go, why is he going that way for? Well, why is she going that way for? But the idea that you can actually see it, you can visualize it, you can sense the city. Was something that, when we're talking with the founder, how do we make that pretty much the iconography of the building, the way the building would perform? It's an extension of the city. And the great thing about San Francisco, it's like New York, it's a vertical city, but vertical in the sense of its topography. So we sort of took the idea of the San Francisco map and turned it vertically. And then started looking at how they behave over there at Uber. It's interesting, doing the analysis, there was this move towards open offices. I think Bloomberg spearheaded that. But now there's a move back to create, people want to have some privacy, some private time. So there's this move more back towards that. But what we found at Uber is 50% of their time is spent away from their desks. They're actually collaborating. So there's a lot of movement going on within the company. And the idea of, again, like Google, creating these sort of then connecting them to amenities or to landscape, opening that whole experience up. And so we took that idea and then sort of coupled it with the idea of the sidewalk and literally started thinking about how we can extend that idea of the sidewalk and connect it with these different activities, these amenity activities. And so these are 3D printed models showing different sort of parties for how that could work through the building. And then we did an unfold, And it's about, we calculate it's about a third of a mile long, that if you stayed on this walk, it would take you through every space in the headquarters. We call this space the Commons, because it's shared by everybody. And we decided, well, why don't we put the Commons out on the elevation of the building? Literally, it's like the app. You're looking at it, you can start to see the activity that takes place. But this is really the shared space for everybody working in that at Uber. And the thing is, we wanted it to be really transparent. So we have skylights at the top and bringing light down. And just one great thing about working in San Francisco is the climate there is pretty great year round. You can open your window. And so the idea is we created a non-conditioned commons so that we didn't have to use IGUs, very thick glass, so we could really create a highly transparent facade on this building. And then there's some views looking into the commons. We took a lot of inspiration from Mission Bay, where the building's located, was a major industry, shipping industry there, a little like the Brooklyn Navy Yard. And so taking some of the colors, some of the qualities of that, and bringing it into the interior of the building. This is a view along 3rd Street. This is a view from the corner of 3rd Street and South Street. And one of the things we thought about, even if you didn't work at Uber, you should have a chance to peek up there and see what they're doing. So at the front door, there's an Oculus, and you can literally look right up into the commons from that point. This is a view inside, street level. And then having a series of bridges. They're actually glass bottom bridges, but one-way glass so that you can't look up, but you can down. But the idea that, it's just that moment of suspension when you're crossing from one building to the next. So the other thing, because of this climate is so conducive to opening the building up, we started analyzing, airflow and heat buildup, and started looking at the idea of maybe the facade is a breathing facade. And using a building monitoring system, we can actually calibrate that facade throughout the day, and it will automatically open and close when the space needs to be cooled or kept warm. So for us, this really becomes the iconography for the whole building. You've got the people moving around, collaborating within the commons, but you also have the skin of the building changing. And it's sort of like this space is a bit warm, so the windows would open up. So the idea is even though they're very simple glass boxes, they're actually constantly, we hope they're constantly changing. So to end on these last two projects, everybody in New York has an opinion. And, it's always about, when we start working on projects in New York, sometimes we don't think about, could we do this project here and do it in Singapore? Could we transplant it somewhere else? I think, when we start thinking about doing work in New York, we really, in a way, we are almost selfish. We do it for New Yorkers. And we think if New Yorkers like it, everybody else is going to like it too. But I can tell you, when developers kowtow to outsiders, New Yorkers usually don't go to those places. The South Street Seaport's a perfect example. They built this sort of festival mall that really belonged in the suburbs. Nobody from New York would ever go there because, why would you go to a mall when you have the island of Manhattan? In a way, it's a huge mall. But this is probably the smallest project to date that we've ever done. This is what we call a talk box. It's a collaboration between public radio, their flagship radio, WNYC. And the idea here was there's a lot of people, the idea of calling in and talking on the radio, a lot of us are quite comfortable with doing this. There's a lot of people that don't have that kind of access. So the idea here was to actually repurpose an old, payphone and basically turn it into a place where people can come, almost a sound studio where people can come in off the street and actually leave a message, an opinion, and it actually would be in real time logged on to the radio station, and they could go through these different opinions and actually put it on live. So this is something that we were asked to look at. We actually fabricated, we prototyped it, fabricated it in our shop. And then we installed it at St. George's Station in Staten Island on the anniversary of Eric Garner's death. And it was amazing the number of people who came and spoke. But what was really quite amazing was the most profound comments came from children. And so you just imagine, you can't think of a child picking up a phone, calling a radio station, and sitting on the phone waiting to get picked up. But here, where they're waiting for the bus or they're waiting for the ferry to get on here, and you pick up the phone and you have a prompt, and it tells you, and usually the way it's set up is the questions are specific to the community. So it's not necessarily a national issue, but it could be a community-based issue. And so you start to hear real-time conversations, and then again, it can be updated. The radio station has direct links to the phone, so they can actually update the questions in real time as well. So it's something that we've done one prototype. Now we're looking at doing a whole bunch and then spreading this idea to a number of other cities. So, and then ending on this project. So, when in New York, it's very much a city of verticality. We've gone to the extremes now. We have now reached the super tall verticality. But when you look at some of this is a really famous work, I don't know the name of the artist, but the city is just all about reaching up into the sky. And when you look at photos from the turn of the last century, the Woolworth building, the first skyscraper, that's the one in the middle, was built in 1912. You start to see this huge juxtaposition between the low-rise buildings and these skyscrapers reaching up into the sky. Because they didn't have air conditioning, mechanical systems at this time, you got these slender towers because you had to be close to a window to get natural daylight, and you had to be able to open it up. So you got these beautiful buildings in Lower Manhattan, one wall, the Woolworth Tower where our offices are, and then the Rockefeller Center. And they really cut a beautiful profile in the New York skyline, the Chrysler Tower, the Empire State Building. And then after World War II, we got a whole bunch, things changed. Companies got bigger, we had mechanical systems, we can handle much bigger floor plates. And so we got a new typology of high-rise construction. But what's happened in the recent years is that there's lots of pockets of additional floor area, FAR, that are being bought up and amassed on tiny sites, and you're starting to get what are called super talls. But in some cases, the proportions aren't too far off. I mean, when you look at 57th Street, our project, the length of one side of the building is very comparable to some of these earlier buildings. That's from the plan of the Woolworth Tower. I know that's from the Chrysler there. But you're starting to see that there is some relationships, but at the same time, it is extremely slender piece of architecture. The other thing, and very similar to the Dime Savings Bank, is we're working on a landmark site. And this is the former home of the Steinway Piano Company. This is where their showroom was. And people go here, they check out the pianos. And so one of the challenges when you're working on a landmark site is you have your project reviewed by the city landmarks committee. And an as-of-right scenario is we could build 120 feet right on the street wall. And we thought, we have the space back here. What happens if we move it back and then lift the tower up, and then we can expose all three sides of the landmark. At the same time, try and bring light back to the interior of the building. We were still required to build an 86-foot street front on 57th Street. If we didn't, we'd probably still try and push it all back to the interior and really open up this building, but because of that, that's as far as we could go. But it was that kind of move that actually Landmarks was quite excited to see. There was a few other things, but the idea that we were pushing the new building back and really bringing the landmark forward and really exposing it to the pedestrians on 57th Street was something that was very, they were very sensitive to. And then redressing the side of the wall with limestone, bringing it down and opening up a new opening into the rotunda of the historic building. This is the commercial entrance for all the retail. The residential entrance is actually on 57th Street, and then there's a poker share on 58th Street. So coming back to this building and thinking about it as a New York building and not something you could necessarily plunk down in somewhere else, but one of the things that really is iconic about New York skyscrapers are the setbacks. And that came as a result of building these first early skyscrapers and not setting them back and creating these dark shadow canyons, which you can still sort of experience today if you're down on Wall Street or on Broad Street or Pine Street. So they created this rule that you had to start setting the building back from the sidewalk. And these are Hugh Ferris's charcoal drawings describing some of those rules. But this is how we ended up, got to the Empire State Building. So we have the same rules here. We have a sky exposure plane. In order to stay out of the sky exposure plane, we create a series of setbacks. We thought, well, why don't we feather those setbacks even further and create many more, and basically based on a rhythm of 5 feet, and basically feather those setbacks right up into the sky. I'll come back to that in a moment. This is sort of looking at the idea that you come off your elevator. The building's almost directly on Central Park, so you have these unobstructed views to the north, and then views to the south, with living on the north side and sleeping on the south. And they do show some of the plans. But one of the challenges of doing these buildings, and technology plays a big role, digital technology plays a big role and is moving the bar when it comes to how we practice as architects and work with builders. But material science is really where the big breakthroughs are happening. On concrete technology, we have 4 columns here. We have the core, and then we have the shear walls that are basically managing the loads and lateral forces in this building. And we started thinking about the fact that you have all these hard surface areas along your east-west facade, and thinking about, the quality of some of these historic buildings, and even in some cases some of the newer ones. This is the Woolworth Tower. And when the architect did the Woolworth Tower, he didn't just put terracotta at the base where you can touch it and see it. He carried that terracotta all the way up into the cupola of this building of the Woolworth. So, this is Louis Sullivan's building on Crosby Street, looking at the level of intricacy and care and craftsmanship that is just taken up through the whole building. You see in the Flatiron building and obviously in the Woolworth Tower. So we started thinking about the possibility, and again, thinking about how this building was not just a place where people would live, but it'd be a bit of a gift to the city, something that people would see from blocks away. And so we started thinking with the idea of the feathered setback that we would also, using the material terracotta, start to warp it back and forth, because on the east and west side of the building we'd get these incredible strong light, and then get these incredible shadows as a result of that. And so it created sort of shadow effect of that feathering that you sort of see on the far side here. And this is sort of a rendering that sort of gives you a sense of that shimmering you get is actually the terracotta warping back and forth in the way that the light is moving across it. And you can just sort of get a sense of that here in this earlier rendering. There's 23 different profiles that are extruded to make those shapes, and they go back and forth. And this is a little mock-up that we did in Styrofoam inside the Steinway Tower. And then our lighting observatoire has an LED light that goes along the side. So at night, just like the Empire State Building and Chrysler Building, the building actually, you'll be able to see that terracotta glowing. Towards the park. Again, looking at how the different faces of the building are detailed. Some potential buyers know. And then, the 2 mass damper, the thing that helps stabilize the bunk is, you have wind loads. We've got some wind catchers in here that let the wind through. But we also have the mass tube damper around here that helps, deal with any type of movement that the building might have. And then above that, you got about 200 feet of what we call vanity height. And people are like, you go to a lot of developers, they're like, I'm not building 200 more feet if I can't lease that space. But that's what these old towers were. They were landmarks. You look at the Chrysler Tower, you look at the Empire State Building, except for the Empire State Building, they were actually making a docking station for airships up there, but it never happened. But the idea is that the towers really reached up into the sky, so there's an opportunity here. As the setbacks keep decreasing, and they eventually come to a 15-foot wide by 60-foot long tub, and that's where the window washing machine goes. And then the possibility of what we could do with lighting to really turn that into a moment that you see, not only from the park, but from other parts of the city. So, obviously this is the high-end side of residential development. I mean, over the past 4 years, we've done close to 1.5 million square feet of affordable housing. And some of the technologies we're using there, modular construction, is addressing some of the issues of how you can get high quality, but for, let's say, a more competitive price. I would say with some of these projects, the technology and the material sciences that we're using here, again, will sort of influence how we work on some of these other projects. So it's not like you're doing design and saying, well, this is great for the 1%, and everybody else has to live another way. For us, it's really about understanding how we can use these different typologies, these different material systems across, in a horizontal way across many different typologies. This is a view from top of the rock at Rockefeller Center. And then that's the group. So just so you know, I'm a twin brother. This is my brother Bill there, and Craig and Kim and the rest of the shop group. Anyway, thank you for listening. Anybody has any questions?
Hi. First off, thank you for your great talk. So in the beginning, we were talking about and it's clear that when you work technology, so pre-launch software has been very intriguing to the process. So in top architects, we go, where's the place of tradition? So like drawing and
Oh.
and what kind of changes in technology?
Well, we do a lot of sketching. And actually, it's funny because yesterday I was actually going through the sketch archives with one of our people because they didn't know what a lot of the sketches were. It was amazing going, oh my gosh, I remember that project. I know that project. No, we sketch all the time. I used to teach drawing before I taught, design studio. And I told the students, if you want to be able to manage the software, you have to know how to draw first because you don't want the menu to control you. A lot of, it's amazing. When I look at portfolios, it's always the same sort of gray renderings. It means that they don't have that sensibility. They're not able to free themselves from the menu to think outside of that. And I think that starts with doing it first, with your hands and feeling that. So it's funny because I started in printmaking and painting. And for me, when I started architecture school, I thought the biggest pain was the parallel bar. To me, it was the ball and chain. I used it to clean my desk. I could draw a pretty straight line without a parallel bar. But I would draw in 3 dimensions constantly and build models a lot. And so when the software came around, it's like a no-brainer. Oh my God, I don't have to draw a plan ever again. I worked at Richard Meyer for a summer. And on Mylar with rotary pens, and you had to erase things and scratch things out, and you dip the pen in your mouth. I was like, this is ridiculous. Sketching and going to the computer, that's the balance that we have at shop. So drawing is very much a part of our process. And even when we're on the job site, we're drawing. But at the same time, we'll also have our laptop with us. We'll do digital scans. We'll overlay the digital scan with a 3D model to see if all the pieces are in the right place. So it's many different tools that you're using, but sketching is very much still part of that process. It's hot. All right. Okay. Thank you.